Hello, grade 9 students, especially to 9 Sulit and 9 Santos. Our lesson for today is all about the laws of sines and cosines. And our objective is to solve oblique triangles using the laws of sines and cosines. But before we proceed to our main topic for today, we are going to review first on the six trigonometric ratios of our right triangles and the special right triangle. So in order for us not to forget the six trigonometric ratios, we always have to remember the acronym SOHCAHTOA. Okay, from SOHCAHTOA, okay, we have sine is equal. So O is opposite and H is hypotenuse. So that is sine is equal to opposite over hypotenuse. Cosine, that is cosine is equal to A is adjacent and H is hypotenuse. And TOA, that is T is tangent, O is opposite, and A is adjacent. Okay, the remaining three, to make it 6, the remaining three are just simply the reciprocal of the first three. The reciprocal of sine is cosecant. Now, if the cosecant is the reciprocal of sine and sine is opposite over hypotenuse, therefore cosecant is hypotenuse over opposite. And the reciprocal of cosine is secant. And if cosine is equal to adjacent over hypotenuse, therefore secant is equal to hypotenuse over adjacent. And the reciprocal of tangent is cotangent. If tangent is equal to opposite over hypotenuse over adjacent, therefore cotangent is equal to adjacent over opposite. Okay. And in a special triangle, we have two kinds, the isosceles right triangle or the 45 90 degrees triangle. In an isosceles right triangle or in a 90 degrees triangle, the formula in finding for the hypotenuse is C is equal to A the square root of 2. And in a 30, 60, 90 degrees triangle, the hypotenuse C is equal to twice the shortest leg and the longer leg B is equal to the shortest leg A times the square root of 3. So those are the formulas that we have learned on our previous lessons regarding the trigonometric ratios and the special right triangle. Now, for example, if A, so we were given in a triangle, if A equals 8, B equals 15, and C equals 90 degrees in a right triangle ABC, find the six trigonometric ratios of angle A. So we are going to divide this into 3. So first is we are going to draw the triangle. So we are going to do the right. So if this is A, this is B, and this is C. We were given that A equals 8 side A, so this is 8, and side B is 15, this side is 15, and we are told this is 90, C is 90, a right angle, and A is the one, angle A is the one that we are told to find the measurement of angle A. So, applying for the six trigonometric ratios, first, in applying the six trigonometric ratios, you have to see to it that the three sides are given. In this case, side C or the hypotenuse is not given, so it is unknown. So before we can use the six trigonometric ratios, we are going to solve first for the length of C. Now, since we have a right angle in a triangle, we are going to use the Pythagorean relation in order for us to determine the value of C. The Pythagorean relation or Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two legs. C is the hypotenuse, so we are going to apply the Pythagorean theorem or relation, that is C squared is equal to A squared plus B squared. Okay, substituting the corresponding value, C squared is equal to A is 8 quantity squared plus B is 15 quantity squared. So C squared is equal to square of 8 is 64 and plus the square of 15 is 225. So C squared is equal to 64 plus 225. You will have 289. Extract the square root. So that is C is equal to the square root of 289. Therefore, C is equal to 17. So C now is 17. Okay. So now, using now the six trigonometric ratios, that is, so sine of A is equal to, this is A, this is the angle A. So sine is opposite. So opposite of angle A is 8 over the hypotenuse is C, which is 17. Cosine A is equal to, cosine is adjacent. Adjacent side of angle A is 15 and the hypotenuse is 17. Then tangent A is equal to opposite of angle A is 8 and adjacent of angle A is 15. Now the three are the reciprocal of the first three. So the reciprocal of sine A is cosecant A. Cosecant A is equal to the reciprocal of sine A. So this, if sine A is 8 over 17, cosecant is 17 over 8. The reciprocal of cosine is secant. So secant A is equal to the reciprocal of cosecant is 17 over 15. Now the reciprocal of tangent is cotangent A. If tangent is 8 over 15, its reciprocal is equal to 15 over 8. Okay, next we are going to have a short review on the spatial angles. So, in the spatial angles we have two spatial angles. So we first is we are going to have the 45 90 degrees triangle. So if we have, for example, if we have this triangle, if this is A, this is angle B, and this is angle C, and this is 45. So this is 45, and this is also 45. So meaning the side opposite the base angles that are congruent are also congruent. So this side must be congruent to this side, and this is the 90 degrees triangle. So if C, for example, this is given, C is equal to 4, the square root of 2, for example, and you are told to find A. So A and B are congruent, so therefore B also must be equal to A. So the formula in finding the hypotenuse of a 45, 90 degrees triangle, C is equal to A, the leg, times the square root of 2. But C is given, so C is 4, the square root of 2 is equal to A, the square root of 2. Dividing both sides by the square root of 2, so dividing this by the square root of 2, so cancel out, therefore A equals 4. Okay, in a 30, 60, 90 degrees triangle, so 30, 60, 90 degrees triangle. So if we have this triangle, okay, if this is A, this is B, and this is C, and if C, for example, if C, this one, this C equals 6, what is B and A? So using the formula, so C is equal to twice A, twice the shorter leg. If C is equal to 6, substitute C equals 6 equals to A, dividing both sides of the equation by 2, cancel out 2 on the right side. You will now have 6 divided by 2 is 3 equals A. So A now is 3. And B has the formula B is equal to A so B is equal to A the square root of 3. So B is equal, A is 3 times the square root of 3. So therefore our B now is 3 times the square root of 3. Okay, so those are the 6 trigonometric ratios and the special angles on how to solve the right triangle. So if the triangle is not a right triangle, meaning in a triangle there is no right angle, the triangle is what we call oblique triangles. And the oblique triangles, the 6 trigonometric ratios are not applicable to solve for the missing parts of the given triangle, and that is where the law of sine and law of cosines come in. So law of the law of sines. The law of sines states that in an oblique triangle, the ratio of the length of the triangle to the sine of the angle opposite that sides is the same for all sides and angles in a triangle. So, in symbols, we have A over sine A must be equal to B over sine B must be equal to C over sine C. This is the formula if you are looking for the missing side. But if you are told to find the missing angle, you are going to use the formula. So that is sine A over A must be equal to sine B over B must be equal to sine C over C. So these are the formulas in finding the sides or angles of a triangle which do not have a right angle, meaning the triangle is an oblique triangle. Now, the law of sines can only be used, so there are 3 conditions to use the law of sines. So the law of sines can only be used if the 2 angles and the non-included sides are given. 2. The 2 sides and the non-included angles are given. And number 3, if the 2 angles and the included sides are given. So these are the 3 conditions in order for us to apply the law of sines. If one of these three conditions are not present, you cannot use the law of sines. So given two angles in a non-included side, that is as. So given triangle ABC with angle has a measure of 30 degrees, angle B has the measure of 20 degrees, and side E has the length of 45 meters. We are told to find the length of side B. So we are going to divide this into 3. Okay. So we are going to draw the triangle. So if this is the triangle, and this is B, so this is angle B, this is angle C, and this is angle A. And based on the given angle A is 30, so this is 30 degrees, angle B is 20 degrees, and side A is 45, so this is 45. Okay, since you are told to find length B, so this is length B. So you can use the formula. So that is B over sine B must be equal to A over sine A. So therefore B is over sine B is equal to 20 degrees is equal to A is 45 over sine A is 30. So cross multiply, you will now have B is equal to 45 times the sine of 20 over the sine of 30. So therefore B is equal to 45 times sine of 20 is 0.342 over sine 30 is 0.5. So B is equal, multiply 45 times 0.342, you will have 15.39 divided by 0.5. So therefore B is equal to 30.78. Since the length of A, which is 45, is a whole number, so therefore we are going to round off our answer for letter B to whole numbers. So B now is equal to 31. So B is 31. Okay. So number 2, another example. So we are given the asa, meaning the two angles and the included sides are given. So we are going to solve triangle PQR, in which angle P is 63.5 degrees and angle Q is 51.2 degrees, and the length of R is 6.3 centimeters. Solve for the measure of side P. So we're going to divide this into 3. Okay. So we are going to draw the triangle. So this is the triangle. So this is R. This is angle P. And this is angle Q. And we were given that angle P is 63.5. So this is 63.5. And angle Q is 51.2. So this is 51.2. And R, so this is side R, is equal to 6.3. And we are told to find this side P. Now, to solve for side P, you are going to solve first for angle R because the side opposite angle R is given. So therefore, to determine the value of angle R, we are going to apply the angle sum theorem. The angle sum theorem states that the sum of all the angles in a triangle must always be equal to 180. So therefore, we are going to add the three angles. So angle P plus angle Q plus angle R must be equal to 180. So angle P is 63.5. So 63.5 plus angle Q is 51.2 plus R must be equal to 180. So adding 63.5 and 51.2, you will have 114.7 plus angle R must be equal to 180. Solving for R is equal to 180. Transpose 114.7 to the other side, it becomes negative. So we'll have negative 114.7. Therefore, angle R now is equal to 180 minus 114.7. You will have 65.3. So this is now 65.3 angle R. Now, you have now angle R, so therefore you can now solve for the length P. So that is P over sine P must be equal to R over sine R. Substituting, you will have P over sine P is equal to 63.5 is equal to R is equal to 6.3 over sine of R is equal to 65.3. So cross multiply, so that is P is equal to 6.3 times the sine of 63.5 over sine of 65.3. So P is equal to 6.3 6.3 times sine of 63.5 is 0.8949 over sine 65.3 is equivalent to 0.9085. Okay, so you have so this is now P is equal to 6.3 times 0.8949. You will have 5.673787 over 0.9085. And P now is equal dividing 5.63787 divided by 0.9085, you will have 6.2. And P now is equal to 6.2. Okay, next, another example. Another example is given two angles and the included side. So we are going to draw the triangle. Okay. So we are given that angle A is equal to 42 degrees, angle B is 75 degrees, and side C is 22 degrees. So we are going to draw the triangle. So for example, this is the triangle. So this is angle A, this is angle B, and this is angle C. And we were given that angle A is 42, so this is 42 degrees. Angle B is 75, so this is 75. And side C, so this is side C is 22. You are told to find side A, so this is A is unknown. So the one that is, we are told to find the length of A. Now, in order for us to determine the side A, since side C is given, you are going to determine first angle C. So again, we are going to apply the sum angle postulates that the sum total of all the angles in a triangle must be equal to 180. So therefore, we are going to add angle A plus angle B plus angle C must be equal to 180. Angle A is 42 plus angle B is 75 plus angle C equals 180. So that is 42 plus 75, you will have 117 plus C equals 180. Solving for C, you have C is equal to 180. Transpose 117 to the other side, it becomes negative. So we have negative 117. Therefore, C now is equal to 63 degrees. So this is now 63. We can now use the formula C. So we have C over sine C must be equal to A over sine A. So therefore, the writing, okay, so C is substituting the corresponding value. C is 22 over sine angle C is 63 must be equal to A over sine angle A is 42. To cross multiply, you will get 22 times sine 42 over sine 63 equals A. So that is 22 sine 42 is equal to 0. So that is 0 multiplied 0.669 over sine 63 is 0.891 must be equal to A. So yes, there is this one. So we'll now have A is equal to multiply 22 times 0.666, you will have 14.718 over 0.891. So therefore, A now is equal to 16.518. And since the length of C is in whole number, we are going to round this up to whole numbers. So 16.5 becomes 17. So this A now is 17. Okay, another example. Okay, example number 4, if the two sides and the non-included angles are given. So we are given that side A is equal to 6, side B is equal to 7, and the measure of angle A is equal to 30 degrees. We are told to find the measure of angle B. So divide this into 3. So we have triangle. If this is A, this is B, and this is C, and we were given that angle A is 30. So angle A is 30. And then side A is 6. So this is 6. Ang side B is 7. So this is 7. And we are told to find angle B. So this angle B. We are told to find the measurement of angle B. So we can use sine B over B equals sine A over A. So sine B is equal to over B is 7 is equal to sine A is 30, and segment A is 6. So cross multiply. So sine B is equal to 7 times sine 30 over 6. So therefore, sine B is equal to 7 times sine 30 is 0.5 over 6. So sine B is equal to 7 times 0.5 is 3.5 over 6. So sine B is equal to 3.5 divided by 6 is 0.583. Dividing both sides by sine, she will have B is equal to 0.583 over sine. Applying the law of exponent, this can be written as B is equal to R arc sine of 0.583. So therefore, B is equal to in your calculator, press the shift or second function and then sign and then the number. So it is equivalent to 35.66. So therefore, since the other given angles are in whole number, so therefore angle B now converting it to degrees is equal to 35 degrees. So this is now 35 degrees. Okay, next. Okay, when the another solutions in solving the oblique triangles is what we called the law of cosines. The law of cosines states that in an oblique triangle, the square of one side is equal to the sum of the squares of the other two sides minus twice the product of these two sides by the cosine of their included angle. So in symbols, it is written as a squared is equal to b squared plus c squared minus 2bc times the cosine of a, or b squared is equal to a squared plus c squared minus 2ac times the cosine of b, or c squared is equal to b squared plus so a squared plus b squared minus 2ab times the cosine of c. So this is the formula that you are going to use if you are told to find the sides. But if you are told to find the angles, you are going to use the formula that is cosine A is equal to B squared plus C squared minus A squared over 2BC, or cosine B is equal to A squared plus C squared minus B squared over 2AC, and the other one is cosine C is equal to A squared plus B squared minus C squared over 2AB. So these are the formulas that you are going to use if the law of cosines is applicable. Now, there are two conditions in order for us to use the law of cosines. The law of cosines can only be used in an oblique triangle 1 if the three sides are given, that is the side postulate. And condition number 2, you can use the law of cosines if the two sides and the included angle are given, that is the side angle side postulate. So these are the two conditions in order for us to use the law of cosines. Okay, example. Two sides and the included angle, that is the side angle side postulate. So given A equals 11, side B equals 5, and angle C equals 20 degrees, find the length C. So we are going to draw first the triangle in order for us to visualize. So if this is A, this is B, and this is C, and where we're given that B is as A is 11, B is 5, and angle C is 20, and we are told to find side C. So this is side C. So we are going to use the formula C squared is equal to A squared plus B squared minus 2AB times the cosine of C. So substituting the corresponding value, so that is C squared is equal, so A is 11 quantity squared plus B is 5 quantity squared minus 2 times A is 11 times B is 5 times the cosine of C is 20 degrees. So that is now c squared is equal to the square of 11 is 121 plus the square of 5 is 25 minus 2. uh, so we are going to multiply 2 times 11 times 5. You will have 110. So 110 times the cosine of 20. So we are going to substitute the value of cosine 20. So cosine 20 is equal to 0.342. 0.342. So c squared is equal to 121 plus 25. You will have 146 minus 110 times 0.342. You will have 37.462. So that is c squared is equal to 146 minus 37.62. You will have 108.38. Extract the square root, so that is c is equal to the square root of 108 times 38. Therefore, c is equal to 10.41. Since the given two sides are in whole numbers, we are going to round up our answer to whole numbers. So 10.41 becomes 10. So our C is 10. Okay? So another example, the three sides, that is the side postulate. The three sides are given. So we are going to draw the triangle. So if this is the triangle and this is A, B, and this is C, and we were given that A is 8, so this is 8. Then B is 19, so this is 19. And C is 14. We are told to find the measure of angle A. So therefore, you can have cosine A is equal to B squared plus C squared minus A squared over 2BC. So cosine A cosine A is equal to B is 19 quantity squared plus C is 14 quantity squared minus A is 8 quantity squared all over 2 times 19 times 14. So cosine A is equal to the square of 90 the square of 19 is equal to 361. So this is 361 plus the square of 14 is 196. So this is 196 minus the square of 8 is 64 over 2 times 19 times 14, you will have 532. Multiply it using your calculator. So you will have cosine A is equal to 361 plus 196. You will have 557 minus 64 divided by 532. 532. So therefore, we have cosine A is equal 557 minus 64, you will have 493 divided by 532. Therefore, cosine A is equal to 0.92669. Dividing both sides by cosine, you will have A now is equal to 0.92669 divided by sine, a cosine, applying the law of exponent. This can be written as A is equal to R cosine of 0.92669. So therefore, angle A is equivalent. So press the second function or shift and then cosine and the number 0.92669 in your calculator, and you will have 22.075. Rounding it up or converting it to degrees, you will have 22 degrees. So angle A is now 22 degrees. Okay? So for your activity, answer it at home in your house. Solve the exercises number 1 and number 2. Okay, that's all for today, and thank you very much for attending our online class. God bless.